So, good evening, guys. Today's topic is class integration, that is user input plus ML model predictions. So, why Flask plus ML? So, basically, the problem is that most machine learning models are developed in Jupyter notebooks and Python scripts. So, but while great for development and experiment, these are not so user friendly or accessible for business teams, end users, and also the clients without coding knowledge. So, Flask is a lightweight Python web framework that lets you convert a machine learning model into a web application that basically accepts user input through APIs, send them your ML model, displays predictions back in a web interface. It allows us to accept input, run prediction, and return output. So examples would be loan approval system. In this, basically user enters income, credit scores. It either gets approved or rejected. And the second example would be iris species predictor. That would be entering four features and getting flower species. And this is the example that we'll be doing today. So basically in Flask, we need to give the user input, then the Flask app, then the ML model works, and then the prediction, and then the output to user is given. So basically over here, ML model makes a prediction. Flask app builds the interface to receive input and output, and the HTML form allows human to interact, and the backend logic is that collects data, it feeds to the model and sends back prediction. So why do we use like Flask with ML is basically for accessibility for non-programmers, as most ML models are in IPYNB files and they are not interactive for users. And Flask grabs the model in a very user-friendly web interface. For example, an HR manager can use a model to predict employee attribution by filling a simple form. An interactive UI for input output. Instead of calling a Python function, user interacts via HTML form fields, button and drop downs, and Flask handles the data behind the scenes and connects it to your model. So basically, Flask apps can run on a server. Every time a user submits an input, Flask routes it to the model and retains the predictions instantly. So it integrates with the front end plus back end, and Flask acts as a bridge between the front end, that is HTML, CSS, JS, and the back end would be Python ML code. So basically, it is also reusable and scalable because Flask app can scale from simple demo projects to production APIs, and you can later upgrade to by adding the authentication, deploy using cloud that would include Heroku, AWS, etc. You can connect to databases, add dashboards with Plotly, Dash, etc. So real world case would be loan eligibility predictor. So the problem is that a bank wants to know allow basically a bank wants to allow users to check loan eligibility. So without Flask, only a data scientist with access to Python can run the model. But with Flask, user visits the website, it enters the income, loan amount, and employment type, and the model returns either the user is eligible or not eligible immediately. So basically, this transforms your model from a technical script into a real application. So the conclusion for this is that Flask lets you take your ML model out of the notebook and into the hands of real users. And it is basically easy, fast, and it is very much ideal for MVPs and real projects. and it works very well with HTML, JavaScript, and CSS. So as you can see this, basically at first user input, then the Flask app, web app is there, then load trained ML model, then the prediction is made, then it shows the result to the user. So basically you can install Python, then you can create a project folder. In this scenario we are going to make Iris Flask app. So we are going to name that, but in this it is written different. So then you need to create a virtual environment, that is basically very much recommended. Then we need to install Flask by using pip. Then we are going to create your Flask app file. So basically in this at the rate app.route, it creates URL likes and predict to trigger model logic. This one. And then we need to run the Flask app, and then you will see a URL, and then you need to do. Now comes the basic folder structure that is very much important. So there would be like app.py file, model.pkl file would be there. And here comes the most important part. Inside templates, your HTML file should be placed. If it is not placed inside it, it will not work, because this is the basic folder structure that is required. And for if you are including CSS or JS files, then you can name a folder like static or etc, whatever the name is suitable, and then it is needed to place inside the static folder. So this is the basic index HTML file. Once again I will say you this folder structure is very much important. Inside templates folder only the HTML file should be placed, or else it is not going to work. This is the basic folder structure that is important. And if you want to place CSS file, then you can place it inside static folder, and JS file as well. Then the HTML, the basic prototype for this index file would be this. So, and the render template is basically it connects Python with HTML. So, like step one is that you need to train and save your ML model. That would be in Jupyter or another script. So, this is the sample data used by logistic regression. Then the second most important thing is that the pkl file needs to be saved, and like after running this, a pkl file would be generated. So that needs to be saved. Post that, the second step is to create index HTML inside templates. So I am emphasizing on this again and again. This is very important. If you're going to make inside the templates folder, only the index file should be kept. And for CSS or JSS file, you can create a separate folder called static, and then you can place it inside over there. So this is a basic HTML form So as we are going to make the prediction, this is used for prediction. Then we need to create a app.py file with Flask code. So pickle load is used over here, and the methods that are used is get and post and app root. So basically, request form is used to collect input from the browser. This is used to collect input, user input from the browser. And debug is equal to true. It helps during model testing. Yes, sure, I will send this file. Then post this, we need to run the Flask app, and this is the work of that AppRoot has done, and then we will read get it. So basically, what is load iris? So load iris is used to fetch the data set. Load iris is a built-in function in Skitlearn that loads the famous iris data set, and we are going to do iris Flask app today. So that this data set is small, clean, and perfect for ML beginners. It only contains 150 samples of iris flowers that is basically categorized into three species, that is Setosa, versicolor, and virginia. And the feature would be sepal length, sepal width, petal length, and petal width. And sepal length is the length of the outer petal-like part. Sepal width is the width of that part. Petal length is inner petal length. Petal width is inner petal width. So why are we taking random forest classifier in this? Because it is an ensemble model. It uses multiple decision trees to improve accuracy, and it works very well with the small data sets, and it requires little pre-processing, produces robust predictions even if the features are slightly noisy, that would be incomplete. And after training, the model learns patterns to predict the correct species based on the input dimensions. And why we are using pickle and what is pickle? So basically, Python's built-in library to serialize objects, that is convert to byte format, and it is very much useful for saving models to disk. Later we can load this model to flash to avoid any retraining, like to avoid retraining every time. So this is used. Pickle is very much important in this. Then we will go, like as you can see in the box, load iris is used to load the data set. Random forest classifier is used to train the model. And why it is used? Because it works very well with a small data set. And pickle.dump is used to save the model for reuse in the Flask. And pickle.load is used to load it in the app.py file. So again, setting up the folder structure. As you can see, the main folder would be iris Flask app, and inside that app.py file would be there. The pkl file, that is the train ml model, that is saved using pickle. As I have stated over here, why pickle, what is pickle? So basically, it is a built-in library to serialize objects, that is basically to convert to byte format, and it is very much useful for saving ML models to disk. So this pkl file is used saving pickle. Then here comes, this is a templates folder. Inside this only the index.html is stored. This structure is very much important because Flask expects HTML files inside the templates folder. So it is very much important to keep it there. So basically, Flask is used to create a web server, and request is used to handle user form input, and render template loads the HTML page. And pickle.load is what it does is that it loads the previously trained random forest model. And approot is it means when the user visits the root of the site, then this function runs. It loads the HTML page containing the form. So basically, over here, this is what the app root does. It creates the URL. So that is root and predict that is there. So basically, it is triggered when the user submits the form and request form. That basically fetches the data entered in the HTML fields, and all the values are converted to float and passed into the model as a list. And the model predicts a prediction of 0, 1, or 2, and based on that number only we map it to the species name, and result is also sent back to the index.html using prediction underscore text. So, and as you can see that app.run debug is equal to true. This runs the Flask app in debug mode, which results showing errors in the browser if something goes wrong. So why are we using post method instead of get? So as you can see that predict methods, in this we are using post. Why? Because we use post because the form is submitting user input, that is sepal length, petal width, etc. So basically that we don't want to get exposed in the URL, because get method appends data to URL, like as you can see that in the URL it exposes the sepal length. If the user wants to give input for sepal length, then it will show the sepal length over here. But it is basically get method is not safe or clean for sensitive or lengthy data. So because of that thing we are using post method, because post keeps the data hidden in the request body, not in the URL. In the URL it does not shows, it just shows like this. But if we use get method after a slash, whatever the inputs we are giving, those field names would be visible. So in order to protect the data and making it more lengthy, we are using post methods. And one more thing, what would happen if we did not cast to float? So basically, user input from an HTML model, HTML form comes in as strings by default, that is text. So if we did not convert inputs to float, the ML model will throw an error like value error, that is could not convert string to float. So basically, if input 5.1 is a string, but the model expects a float like 5.1. So we must use float request form sepal length to properly feed numeric data to the model. So basically, why do we return the same HTML page instead of a new one? So we return using a render template. So that is because the form remains visible to the user. So they can also modify and resubmit, and the prediction result is displayed on the same page below the form. It improves the user experience and keep interaction seamless. But what if we return a different HTML page? The user would lose their input fields and also be redirected to a new page and find the experience less intuitive. So because of that reason, we are using the same HTML page instead of a new one, and we are showing the result also, like the prediction result is also displayed on the same page below the form. So as you can see, the quick summary of why we are using post, because to hide form data and handle larger and more secure inputs. And why we are using float, because ML models need numerical input, not strings. Also, like why we return the same HTML. So for better UX, form and result on the page. So AppRoot is that it shows the homepage HTML form, and this AppRoot predict it receives data, predict returns, and return results. And request.form is that basically it access user input, and render template what it does is that it loads HTML and passes result back. And model.predict what it does is that it uses train model for output. So here we will create the HTML form. Again, I am putting emphasis on this. The index file should be placed inside the templates folder, and the template should be written as it is, because it should not be in uppercase. It should be in lowercase. Everything should be in lowercase. So as you can see that here we are using the post method, and the label is sepal length. Here is sepal width. Input type is text, and the name for this is sepal width as well, this label thing. And third label is petal width. Fourth one is like we are submitting, and the value predict form, and this is used for prediction. So for form action, that is predict method post, that basically sends data to the Flask predict route, and the input time, that is text. Over here it collects sepal petal measurements. Input type, that is equal to submit, that submits the form. And this if prediction underscore text percentage, that is conditional. If prediction exists, it will display it, and this prediction underscore text, it displays a result using Zinza 2 templating. So why do we use name in the form fields? So the name attribute in HTML, that is input tags, is essential because Flask uses it to identify and extract the input values from the submitted form. So as you can see, this input type is equal to text name sepal length, request form sepal length. So here sepal length matches the name in the HTML. Without name is equal to, Flask won't know how to assess the field's value. So basically, the name acts like a key that Flask uses to fetch the corresponding entered value from the form. Okay, then we will proceed to the code. Then I will again explain some of the questions. So as I have mentioned it, that we are using the iris dataset that consists of 150 sample data, and there are three species, that is Setosa, versicolor, virginia. We are going to input sepal length, sepal width, petal length, and petal width. And as I've stated about the debug is equal to true, also a render template as well. So this is the code. I have saved the index file inside the templates folder, and the folder name is for iris underscore flask underscore app. Inside this, a pkl file is also saved, that is iris underscore model dot pkl, that is the file that is trained. So as you can see, as you can see, the prediction is also given in the same page. As I have stated, that it is not taking two HTML page. It is being shown in the same HTML page. So this is the work that AppRoot does, and because of get method, the fields are not displayed over here. And if we would have used get methods, then it would have, in the URL itself, the sepal length and etc. would have been displayed over here. So please go through the code once. Once again, we'll go through the iris predictor. So as you can see the prediction is also shown in the same page itself. So if we are entering any values, a predicted species would over here. Okay, again the Setosa came. Okay, so see, based on the lengths that is provided, sepal length, sepal width, petal length, and petal width, based on the inputs, the predicted species over here is versicolor. Again, the versicolor came. So in this scenario, the predicted species is Virginia. So that's how this iris species predictor is working. So basically, it is returning the same HTML because for the better UX and form and result on one page only. So because of the more intuitiveness, it has been done. So it is displaying the form and the result in the same page. So basically, how does the form communicate with Python? Because when the user submits the form, so form action predict method post is there. So here is what happens is that browser sends a post request to the Flask server at predict, and then Flask uses a use request dot form sepal length to extract the form data. So this data is passed into the ML model for prediction, and then Flask sends a response back to the browser. And the name is equal to is that it identifies form fields for Flask to assess, and request dot form is that it gets the data from user input. Action is equal to in double inverted commas, that is predicted, it basically sends form to Flask root. And Zinza 2 is that it dynamically updates HTML with Python variables. So please go through the code once, then once again I will show this one, then we will proceed to. So this is the basic, this is the, so the predicted species is Virginia. So this will be used deployed using Flask. So because of the UI thing, we are using Flask. Yes, I will be sharing it. Oh, acha, you want to share, like, you want to share me the code in the screen, or you want me to share the code through the email? Okay. So why we are using, what is Jinja? So why we are using this? So Zinja 2 is the templating engine class that uses to render dynamic content in HTML. So it lets you embed Python like variable and logic inside HTML using special syntax like this. So for this, as you know that this is placed inside the index file. So this does two things. Basically, it checks if the prediction exists, and if it does, the prediction inside a paragraph tag, like it basically displays it inside a paragraph tag. So what is prediction text? So basically, because what render template does is that it shows the prediction underscore text, that is your result is here. It sends that variable into the HTML where this prints it. So as I will do a brief summary. So the name is equal to is the identify form fields for Flask to access. Request.form is the like where the purpose is that it gets data from user input. And action predict is that it sends form to Flask root. And Zinja 2 is that it dynamically updates HTML with Python variables, and prediction text, it injects prediction result into the HTML. So once again, I'll explain this one because the significance of this is that because of the Zinja 2 template, it is a templating engine class that uses render dynamic content in HTML. So it basically lets you embed Python like variables and logic inside the index file, that is HTML file, and by using the special syntax like this. So this basically does two things. It checks if prediction task exists or not. And if it does, it displays the prediction inside a paragraph, that is p tag. So why prediction text? Because render template index.html prediction root sends that variable into the HTML where this prints it. And as it is stated, it is inside a paragraph tag, so that's why. So this is the closing tag of paragraph tag. So once again, this is the name is equal to is that it identifies forms and forms fields for Flask to access. Request.form is that it gets data from user input. Action is equal to predict is that it sends form to Flask root. Ginger 2 is that it dynamically updates HTML with Python variables, and prediction text injects prediction result into the HTML. So now we'll have a quiz. So what does at the app root decorator do? Please pop in your answers in the chat box. You guys can turn your mic and answer it as well. So basically, what does the app root do? Only four of them has answered. Yes, C is the correct answer because it maps a URL path to a function. So why do we use post in a form instead of get? C is the correct answer because it hides data and is safer. So what is the role of name is equal to in an HTML input tag? Yes, it helps Flask retrieve the data. So in Flask, how do you get the user input name, sepal length? What is the correct option from here? So C is the correct answer. Actually, request.form sepal length is the correct answer. So what would happen if we forgot to cast user inputs to float? Yes, D is the correct answer. So what does render template index.html prediction do? So B is the correct answer. It returns an HTML page with prediction inserted. So what is Jinza 2 used in Flask apps? Yes, that is correct. Rendering HTML with Python variables. So what folder must contain index.html for Flask to find it? Yes, templates is the correct answer. So in a Flask project, what file typically handles routing and backend logic? Yes, D is the correct answer. So last question is, what is the purpose of saving the model with pickle? Yes, C is the correct answer because it is done to reuse it later in Flask without retraining. So that's it for today. We will be wrapping up the session and I will share the documents over the mail. Actually, the support team will share the documents. So that's it for today. And even the iris data set and the files for it, I will I will share it. But since I cannot share the templates folder, what you guys can do is that after downloading the file, you can place the index file by making a templates folder and the main folder for iris flask app. Then you can run it. I will make sure the file is shared with you guys. Okay, then yeah. Thanks for joining. We will be wrapping up the session.